This video is on solving word problems involving quadratics. Here's my first example. When a number is added to its square, the result is 6. Write an equation in x and solve to find two possible answers. Verify your solutions. Now, first of all, just in terms of the language that's being used here, when it says to write an equation in x, this just means call the number that you're looking for x. We can say that x is our variable. We can also see that the question says that there will be two possible answers. This is often a clue that you're dealing with a quadratic problem, because as we've seen when we've been solving quadratics, we get two answers at the end. We're also asked to verify our solutions, and this just means check your answers by subbing them into the equation that you make, and this is a lot like what we do in simultaneous equations when we take our answers at the end and sub them back in to check that they actually work. So now let's go about building the equation. So it says a number is added to its square. Okay, so we need to first of all decide what are we going to call this number? Well, they've told us in the question to write an equation in x. So the number that we don't know is what we're going to call x. So we've got a number and we're adding it to its square. So that's going to be x squared plus x. So I'm adding the number onto its square. And I'm told in the question the result is 6. So that equals to 6. And now I want to solve this. Well, I can already see that it looks like a quadratic. It's got an x squared. It's just got one little issue, which is that it's not equal to 0 at the moment, but I can sort that out pretty easily by just bringing the 6 across the equal sign. And now I've got a quadratic that I can deal with very nicely. Just get our guide number, factorize, break it up and factorize as normal. One little hint or tip here. We already know that the x squared has a coefficient of 1, and just to point out that the x, the middle term in this quadratic, also has a coefficient of 1. So we'll just bear that in mind when we're picking the set of factors of our guide number that we want to work with. So at this stage, you should be well able to factorize and solve this quadratic yourself. So pause the video here and do that and then play and see if you're correct. And we'll start by getting our guide number. So our guide number is 1 by 6, which is 6. And then, of course, we need to factorize that guide number. And we could have 1 by 6 or 2 by 3. I need to make a 1. And of course, I've got a minus here at the end, which tells me that I have to use different signs with the numbers from my guide number factors. So 1 plus and 1 minus. So plus 3 minus 2 will give me plus 1. So I'll go with those. So I've split up my quadratic like this, and now I'll factorize. And then my last set of brackets is going to be x minus 2 by x plus 3 equals 0. So these are the factors of my quadratic. And now I want to get my roots or my solutions. Again, let each bracket equal to 0. And then I'll just solve for x. So in this case, I get x equals 2 and x equals minus 3. So let's just go back and refer to the question again for a second. It said write an equation in x. That was this first line here. Then it says solve to find two possible answers. Here are my two possible answers. And then it says verify your solutions. So to verify my solutions, what I need to do is take each of my solutions for x separately and put them back into this equation and see if they work. So let's start with 2. So I sub 2 in for x in my equation, and I'm putting brackets around each time I sub in the 2. And then I go to my calculator and I type in the left-hand side and I see, does it come out like it's supposed to as 6? And when I type in 2 squared plus 2, I do get 6 on the calculator screen. So 2 works out fine, correct. Now I'll do it for the minus 3. It's particularly important when you've got negatives to make sure to include your brackets, because if you don't, you won't get the right answer. So typing in brackets minus 3 squared plus brackets minus 3 equals 6. Well, I can't type in the equals 6 bit, just the bit on the left, into the calculator. It comes out as 6 on my screen. I'm correct. And since both of these give the expected answer of 6, I can accept both as correct solutions. This means that if I take 2 and add it to its square, the result is 6. And if I take minus 3 and add it to its square, the result is 6. So here's a second example. So if twice a positive number is subtracted from its square, the result is 15, and I want to find the number. A couple of things to watch out for here. The fact that the question tells us that it's a positive number means that at the very end, we must only take positive solutions. It doesn't mean that I have to force pluses into the question as I'm making the equation. It just means I have to be careful at the very end. In this case, they don't say to write an equation in x, and they don't say to find two possible solutions. So you might think that guessing the number is fine, but actually it's not. We really still have to make an equation. And the clue in this case that it's a quadratic is the reference to the square. So just bear that in mind. Even if it doesn't say you have to make an equation, you really do have to make an equation. So take a moment and see if you can figure out what that equation should look like yourself. Okay, so we're told to take twice the positive number from its square. So we're going to call that number x. We tend to use x a lot as the variable. You could legitimately take any other letter that you wanted, but we'll just use x because that's the one that gets used the most commonly. Okay, so our equation will look like this. X squared minus 2x equals 15. So I'm subtracting twice a positive number from its square. Notice what I said at the beginning. This positive bit here just means that at the very, very end, my answer must be positive, but it doesn't stop me from using minuses in my equation. The result is 15. That's where the equals 15 is coming from. Again, it's a quadratic. What do I always want to see with quadratics? They have to be equal to 0 before I can begin to solve them. So we need to sort that out first of all. So we'll bring the 15 across. Okay, now I want to factorize. Don't forget, that's a 1x squared. Make your guide number, factorize, and see how you can break up your quadratic. Pause the video here while you do that, and then work through to the end of the solution of the quadratic, and then play and see if you're correct. So my guide number will be 1 by 15, which is 15. I'll factorize the 15. This gives me 1 by 15, or 3 by 5. This minus at the end of the quadratic tells me that I have to use different signs with my factors to make the minus 2. So I need a plus and a minus. So plus 3 minus 5 will give me minus 2. And now I'll factorize that. And then my last line of factorization will be x minus 5 times x plus 3 equals 0. So here's my factors. Now I get my roots. So I first let each factor equal to 0, and then I solve for x. Now, this is where I have to think about the requirement in the question for there to be a positive number. So we're told that it's twice a positive number is subtracted from its square. So when I look at my two solutions here, I've got 5 and I've got minus 3, but only one of these is a positive number, and it's the 5. And just remember that if there's no plus in front of a number, it's automatically a positive number. So x equals 5 is my solution. It's very important at this stage in a question, if I get a solution that I can't accept, to clearly show that I can't accept it. To do this, I'm going to just circle it and draw a line through it. It's not that I don't want to be able to see it. I want to be able to see it, but I want to see that I'm rejecting it. And it's also a good idea to make a statement about why you're rejecting it. So I'm putting a line through it and saying, well, minus 3 is negative, so I can't accept it as a solution. X equals plus 5, on the other hand, is fine because it's a positive number. The question in this case hasn't asked us to verify our solution, but it's always a good idea to do it just for yourself so that you know that you're right. So what I would suggest doing at this point is taking that 5 and subbing it into the quadratic just to double check that it works. So on our calculator, we can just type in 5 squared minus 2 times 5, press equals, it comes out as 15, which is exactly what I need based on the equation up here. So my 5 is a positive, I can accept it, and I verified it to be 100% sure that it actually is the correct solution, and now I'm satisfied that I'm finished the question. Okay, so here's example 3. It says one positive number is 5 times bigger than another. So we're talking about two different numbers here. When I find their product, I get 14. Find the numbers. Just note here that it says find the numbers. So I need two parts to my answer. The positive number and the positive number that's 5 bigger than the first one. Again, I don't explicitly say in this question to make an equation first, but that's implied. We want to make the equation, we want to do our quadratic, we want to do our factorizing and solve and show all our work. A good idea when you've got a question like this, where you've got a number and then a number bigger than it, is to actually write down a little statement for each before you begin. So I've got a smaller number and a bigger number. I'm going to call the smaller number x, and I'm going to call the bigger number x plus 5. These two numbers, the smaller number and the bigger number, are the ingredients for my equation. So it's a good idea to have them written down first so that I know what I'm using. Okay, so it says I'm finding their product. Now, product, of course, means that I want to multiply the numbers together. So I'll write that down as x bracket x plus 5, and the result I'm told is 14. Okay, so I see that I've got brackets in this, and I want to find the product. So, of course, the natural thing to do here is to actually multiply it out, which gives me x squared plus 5x equals 14. And now I'm back to familiar territory. This looks like a quadratic, but it's not equal to 0, so I try to make it equal to 0. and then I factorise and solve. So again, make your guide number, etc. and pause the video while you do that, and then play at the end and see if you were correct. Okay, so my guide number is going to be 1 by 14, which is 14, which I'll factorise to give 1 by 14 and 2 by 7. And again, it just so happens in this case again that I've got a minus at the end, so the signs must be different. And that's grand because 7 minus 2 gives 5. So I'll write my quadratic now as x squared plus 7x minus 2x minus 14 equals 0, and I can factorise. So first of all, as x by x plus 7 minus 2 by x plus 7 equals 0. So my brackets are x minus 2, x plus 7 equals 0, and then let each bracket equal to 0, and then solve for x. So I get x equals 2 and x equals minus 7. At this point, when I've solved and got my solutions for x from my quadratic, it's important that I go back and read the question. So notice it said one positive number is 5 times bigger than another. So again, looking at my solutions here, I can see I've got a positive answer, I've got a negative answer. So I can only accept the positive answer. And I clearly note that it's negative, I can't accept it. Just note, by the way, negative numbers in themselves aren't a problem. It's only if there's an issue within the question, if they've stated, for example, that they only want to accept positive numbers. Okay, so we don't automatically cross minuses out, only if the question says that we have to. Okay, so the next thing is that there was 2 numbers involved. So now that I've crossed out minus 7, I only have this one answer of 2. But the 2 answers that I wanted were my smaller number and my bigger number. So I've found the smaller number x, because I have x equals to 2. And now it's easy to find the bigger number because I can just say x plus 5. Now that I know that x is 2, that means I'm just looking for 2 plus 5, which is 7. So my 2 solutions are my smaller number x, which is equal to 2, and my bigger number x plus 5, which is equal to 7. Again, like before, it can be really tempting at the start of one of these questions to say, oh, I can already see what those numbers should be. But we can't do it by guesswork. That's called doing the question by inspection. We have to do it by calculation, by making the equation. Here's example 4. In this example, we have a diagram. We can tell that it's a rectangle because we're told that we've got a right angle. We're told that opposite sides are equal in length. You can see that from the dashes. And opposite sides are also parallel, which we can see because of the arrows. So it says in the question, the area of this rectangle is 30 centimeters squared. Find its length and width and use these to find its perimeter. Okay, so there's a couple of bits in this question. Again, like before, there is a requirement to find unknown values. We don't want to do it by guesswork. We need to do it by making our algebra equation, by making our quadratic. So just make sure that you do go through that step. Don't just go looking for values that'll work to make 30. Okay, so it's a rectangle, so how do I get its area? Well, the area of a rectangle, of course, is length by breadth, or to use the language of this question, length by width. So I'm finding the product of my 2 dimensions here, my x plus 3 and my x plus 2. And since I'm told that the area is 30, x plus 3 times x plus 2 equals 30. Okay, so we see 2 brackets multiplying together, so we're going to want to multiply those out. Don't forget, we can do that by splitting up the first bracket and multiplying each term in the first bracket by the second bracket. Pause the video here and see if you can do this yourself and try and form this into a regular looking quadratic. So first of all, I split up that first bracket, and then I multiply, and then I tidy up slightly. But I don't want it equal to 30, I want it to be equal to 0, so the 30 is going to come over. And then I'll finally tidy that up to give me the quadratic x squared plus 5x minus 24 equals 0. So now I'm going to solve this out to figure out x. As always, the coefficient of x squared is 1, and my guide number in this case is 24. So here are the factors of 24. This minus in front of the 24 tells me that I have to use different signs, so a plus and a minus. So I can use 3 and 8 to make 5. Okay, so I'm going to have x squared plus 8x minus 3x minus 24 equals to 0. And now we'll factorise. And we'll end up with x minus 3 by x plus 8 equals 0. And my 2 solutions then from that will be got by letting each of those brackets equal to 0 and then solving. So x equals 3 and x equals minus 8. Okay, so as always at the end of a question like this, I have to go back and look at what they're actually asking me before I conclude. So I've got my 2 solutions for my quadratic, x equals 3 and x equals minus 8. But if I look back at the question, they're asking me to find the length and width of the rectangle. Okay, so let's just take a moment there to check. Are there any issues that might pop up? Well, if I've got x equals 3, that means that x plus 3 would be 6, because that's just 3 plus 3. and x plus 2 would be 3 plus 5. Sorry, 3 plus 2, I should say, which is 5. So there's no problem with that because 6 and 5 are perfectly fine as the size of rectangles. But what would happen if I used the minus 8? So if I said minus 8 plus 3, that's going to give me minus 8 plus 3 is minus 5, that's a negative. And minus 8 plus 2 is minus 6, and you can check that in the calculator if needs be, and that's also a negative. But I've got a problem here because I'm dealing with a rectangle. And when I'm looking at measurements are always going to be positive. You've never seen a minus sign on a ruler because you can't measure negative distance. It just doesn't exist. So even though the question itself did not say that I had to take positive solutions, the fact that I'm dealing with distances means that I need to make sure that my distances are positive. So if I use x equals minus 8, I run into difficulty there because I'll have minus distances. So I'm going to make a note of that by saying that distance can't be negative, and minus 8 plus 3 is minus 5, minus 8 plus 2 is minus 6. So that means I have to eliminate x equals minus 8 as a possible solution. I don't have a problem with the x itself being negative. It's that when I put it in to the expressions for the length and width, that the length and width end up being negative. That's where I've got the problem. But x equals 3 doesn't cause that problem, so I can accept that as an answer, and I can use it to work out my length and width. So when I find x plus 3 and x plus 2 using x equals 3, I get 6 and 5. So 6 is the width and 5 is the length. And I'm going to be able to use these now to find the perimeter. So the perimeter of a rectangle is twice its length plus twice its width. So I fill in 5 and 6 for length and width, and I calculate that, and I get the perimeter is 22 centimetres. Okay, here's our last example for today. So Jill is X years old. Her mum is the square of Jill's age, and her dad is 5 years older than her mum. And I'm told that the sum of their ages is 60, and I want to figure out how old is Jill. Okay, so I've got 3 people involved here, Jill, her mum, and her dad. And I'm going to try and first of all write down an expression for each of their ages. So it's easy to get Jill's age because she's just X years old, so I'll write X in for her. Her mum is the square of her age, so that's just going to be X squared. What do you think I should write down for her dad? Her dad is 5 years older than her mum. So her dad will be her mum's age, X squared, plus 5. I'm told in the question the sum of their ages is 60, and of course sum means that I add, so I add all these expressions up and I get a result of 60. So I've got Jill's age plus her mum's age plus her dad's age equals 60. And again, I can see the beginnings of a quadratic here because I've got the x squareds. So I want to tidy it up into a regular looking quadratic, and then I'm going to factorize and solve. So pause the video here, do that yourself, and then play and see if you're correct. So first of all, I'll tidy up the left, and I'm putting the x squared terms at the start, and then I'll bring the 60 over, and then I'll tidy up slightly again. Okay, so now I have my quadratic that I want to work with. So as usual, I'll get the guide number and I'll factorize, and let's just notice here that the coefficient of x squared is 2 and my constant is 55. So what's my guide number? The guide number is 2 by 55, which is 110. So now I need to factorize that 110. So there's my list of factors, and I want to make x in the middle. Don't forget x is the same thing as 1x. This minus here means that I'm using different signs. So which set of factors can I use different signs with to get 1x? Well, it's going to be the 10 and the 11. So here's my quadratic then broken up, and then I'll factorize. Okay, so we have the factors now of our quadratic, and we need to solve. We let each bracket equal to 0. And we get a very straightforward x equals 5 for our first solution. When we're solving this guy, we're going to have to bring the 11 across first of all, and then divide by 2. So we get 2 solutions, x equals 5, x equals minus 5.5. Again, we need to go back and reread the question just to be sure that we're answering exactly what they want. So if we go back and review the question again, remember it's about Jill and her age. We want to find out how old she is. So that obviously has implications for the type of answer that we can get, because if you think about somebody's age, it's always going to be what kind of a number? A positive number. So when we look down at our solutions at the end, x equals 5, x equals minus 5.5. Nobody's ever going to say to you, I'm minus 5.5 years old. It doesn't make any sense. So we're going to eliminate that as an answer. We're going to explain why we're eliminating it. And that means then that Jill, of course, must be 5 years old. Sometimes in a question like this, you might be asked to get all of their ages. That would be really easy to do. So Jill is 5. Her mum is the square of her age. So square 5 to get 25. And her dad's age is x squared plus 5. So we just sub the 5 in for x and work it out that he's 30. I wasn't asked for that in this question, but I might be on occasion. So just watch out for that you make sure to fully answer the question. And it's always a good plan when you have your answers to go back and just read what the question asked again, just to be sure that you've covered everything.